Hey everybody, it's Chris from Side Effects. Welcome to Hex, Episode 3. Okay, before we dive into this Hex, a quick update on Mardini, the daily art challenge for the month of March. Every day, artists were submitting entries to be judged based on themes each day. The contest is now closed. The winners have been selected and will be announced very soon. Coming up on April 22nd, we'll be hosting a Mardini Hive, where some of the top artists will be presenting on their entries. So please mark that day in your calendar and join us if you can. Okay, on to the Hex topics. So first up, we talk with Grant Miller from Ingenuity Studios on their work on the TV show SWAT and how they incorporated Solaris into their pipeline. Next up, Rob Stauffer talks with Matt Pukela about his Axiom Houdini plugin, a sparse GPU-accelerated volumetric fluid solver. Then we speak with Jerome Hareng from Virtuo Sparks about their work on the beautiful Demon's Souls cinematic. Next up, Fiona Wong talks with Hristo Velev from Bottleship VFX about their work on the Netflix film Space Sweepers. Next up, Paul Ambrosiuson talks with Valentine Kozin from Rare about deep learning for VFX and games. Simon Verstraet, Rob Stauffer, and myself will tell you about our new demo and learning project we've launched for 2021 called Titan. And finally, Jeff Wagner speaks with Rob Hopper from Union VFX about their work with KineFX for crowds. All right, I'm here with the guys from Ingenuity Studios. Hey, guys.
How's it going?
Howdy.
Great. Maybe you could introduce yourselves.
Sure. I'm Grant Miller. I'm a visual effects supervisor and one of the owners here.
I'm Chad Wandestreet. I'm the client-side VFX supervisor for the show SWAT, one of the many shows that Ingenuity works on.
So let's talk about Ingenuity a little bit. Where are you guys located?
We're here in Hollywood, California, for our main office. And then we have another office in Vancouver and New York that kind of service those markets. And we're opening up a fourth office in Atlanta.
What kind of projects do you normally do?
We typically work on television, film, commercials, and music videos. The television stuff makes up probably 60% of our work, and the other 40% is rounded out by the other stuff. But the variety, I think, keeps everyone interested and gives a lot of good training opportunities for the artists.
So let's talk about your pipeline and how Houdini fits into it. What are some typical challenges that you guys face at the onset of each new project? Like television is challenging, as we all know. What are some of those challenges?
Yeah, I mean, we're kind of always up against time, especially with television. Everything has a 2 or 3 week turnaround max. So you're not, afforded the luxury of 3 months of prep time and dev time. We're always trying to kind of work procedurally in order to start things as soon as possible, which I think is kind of one of the things that we really like about Houdini. It's the main hub for our productions. So it's our main lighting, layout, scene assembly, everything kind of runs through there.
So what are some of those advantages of proceduralism in that context?
For us, it's just being able to start things as early as possible. The second we have an asset, even if it's just a V1 blocking, we can dress a scene with that and, know that it's going to update as the asset gets finished. Just from a lighting and kind of look dev standpoint, we can plow through a lot of shots really quickly, especially stuff that has the same lighting setup. It's easy to pull in, 10 different cameras and run through all the shots in one go. So there's a lot less, opening and closing and keeping references everywhere, and, just manages the scenes, I think, in a much more efficient manner.
I think from my standpoint, it allows them to iterate much quicker, right? That's one of the big advantages of the procedural pipelines is we start something and we're tearing through looks, as Grant knows, rather rapidly. Huge.
Right on.
Yeah, I mean, you can be working with something that's not finished, but have the confidence that what you're building is going to go into the final shot, as opposed to kind of waiting and being blocked by the upstream departments. And I think that's really important.
So what are some examples of work that you've created using Houdini?
I mean, we've done the gamut. We do a ton of fire and explosions and stuff for SWAT, obviously, but we also do typical CG work, like CG set extensions and cars and stuff like that. Helicopters. We have been doing a lot of creatures and like bigger, larger, like environmental set extensions lately. I think just from the pandemic, like you can't really go shoot anywhere. So, we're now creating 16 kilometers of Scotland to run a train through because you can't, film in Scotland, or we're creating, all of downtown Los Angeles because you can't film in downtown Los Angeles anymore. So really a very wide gambit of stuff.
Yeah, we've all been curious about how that is going to transition with COVID, being able to continue the work. And I think digital has become an extra important factor in the production pipeline.
Yeah, I mean, at the beginning of SWAT this year, we knew that we weren't going to be able to pull permits for downtown LA. So it was like, we're just going to build the whole thing in the computer. And, we had the lead time, thankfully, to kind of make that happen and make that a reality. And then it's paid off once the episodes are here because, we can kind of park it wherever and, have a background that we wouldn't be able to really achieve in this kind of current time.
Yeah. I mean, for the showrunners and everything too, it's huge because we bring them and show them, here's a new view of LA. Here's a new view of LA. And their mind is completely like blown, right? How quick, like in a couple of days, we've got a blocking and all these things, everything set up. So that part, being able to iterate with them on these large, scenes has also been great. But I mean, from a production standpoint, yeah, we still like can't film downtown. There's like 2 streets basically that we can film on. And, that gets old. So it's a lot of like backlots and extending backlots. And these guys are, helping with that a ton.
That's great. So let's talk about SWAT a little bit. Just give us a 10-second summary of what the show is and what it's all about.
At the core, we're kind of a procedural, crime drama. But thankfully, this year has really set the stage for a lot more like issues that they're dealing with around cops and racism. And, the city of LA is kind of a center for that. Most of our visual effects are story-based. So it's, they're meant to kind of not be seen a lot of times. And these guys do a great job with making it big, but not making it obvious. We've got a huge stunt department and special effects department that we kind of work with a lot of the time. So in that way, it makes it, it's a little bit old school.
Invisible effects.
Invisible effects, it is.
They also do a really good job of, giving us something to work on. Like if we're, throwing a Molotov cocktail into a store, we'll have a practical fire there and we'll just be on the hook for the Molotov-y portion. And that, I think that combo really is what makes the whole thing work. It's people kind of have a, CG has a bad rap of looking fake and, but it's really just bad CG that looks fake. And I think the good stuff you don't even notice. And, that's really, where we try to operate.
100%.
Well, it's great working with a kick-ass special effects department too. Like if we had a whole back lot that was on fire and these guys did the effects for it. And I wanted some reference for something very specific. So I called up those guys. I'm like, dude, I want to burn down our back lot and light some stuff on fire. And they're like, yeah, let's do it. So like we're out there with a video camera shooting reference for these guys. Like, that's fantastic. They're as involved and engaged, and they'll critique our work sometimes. The special effects coordinator will come up and go, that looks great. Or, you know what you need on that one next time. It's like, that kind of dialogue with them is huge and helps the whole process.
That's awesome. Love to hear that. So let's talk about one of the key shots that you used Houdini for.
Yeah, I mean, the initial downtown LA set extension really, took us through a lot of the developments that we made over the pandemic. When it first hit and everything kind of shut down while everyone was freaking out and wondering if the world was going to keep spinning, we took that opportunity to kind of push into USD and Solaris, and kind of chose this downtown Los Angeles set extension as like a first real production test space to use that stuff in. And it was, worked out really fantastic. I mean, the level of detail that we're able to have in the city, the, workflow from just kind of a streamlined standpoint was all really solid. Certainly some, bumps along the way, but overall really positive experience. And we've continued to do that for the rest of those shots throughout the season.
So how long have you been using USD?
We've been using it since March of last year, and then started doing kind of full production work with it in the summer of last year. So like June, July.
And were you into Solaris right away, or were you using USD before Solaris?
No, just straight to Solaris. So we made the switch and then started doing, Maya USDs out and kind of doing full scene assembly in Solaris.
And what have been some of the challenges on transitioning into USD in Solaris?
Getting the resolver set up was a big component. There's not a lot of great kind of documentation for how that should be done and how it should work at a, pipeline level and a studio level and stuff like that. It's, it's very bespoke everywhere and people are kind of pretty closed about it. But other than that, it was pretty smooth, I would say. That, the actual core library has a ton of documentation. Houdini has a ton of great examples, and we transitioned to RenderMan at the same time, and the RenderMan USD, it's kind of the gold standard. So that really works well together, and being able to, have a tree that's shaded and lit and, dump it over and have it in the Houdini side of things from Maya's, but still be able to edit the materials and have a fully workable asset is just great.
We've heard that from some smaller studios that they feel like USD is just for big studios. So it's great to hear that applies quite well to television.
Yeah, I feel like it couldn't be further from the truth. Like we've we did music videos were like our initial production testing for like just trying stuff out and seeing if we can run little scenes through it. And even for that smaller stuff, it's really nice because the way we have the assets set up, they're just always updating to the latest of everything. So you can, block out that entire Scotland scene that I was talking about earlier, block it all out with, cone trees and, little rough rocks and whatever. And you can know where the scene is going to, go from the get-go and then just watch it update. So it's really nice to work in just very iterative fashion.
Looking back at the project, what was your biggest accomplishment? What do you feel most proud of?
I feel like we were really able to accurately depict downtown Los Angeles in a very photoreal fashion for the show in a time where they couldn't film there. And we were on a studio level able to push just a ton of, digidoubles and tons of cars and just a lot of really rich environment work out. In a pretty tight turnaround, and I think kind of push the pipeline forward in the process. So it's just kind of a win all around, I think, for everyone.
Yeah, that's absolutely true. It was like devastating for us not to be able to go down there, and I think a lot of the shots that are actually for the like showrunners and stuff, the most interesting are like the textural things where it's like, heavily depth of field and you have all that texture back there, things moving, people walking, and you can tell stuff's going on and there's dialogue and whatnot. But those aren't like our hero shots, but they're still, for them, it blows their mind. Every time they see them, it's like, oh my God. But yeah, it was absolutely incredible.
Yeah, I feel like television has really taken a step up in the last few years towards movie quality. And it's thanks to, studios like yourselves and shows like yourselves pushing that. So as a viewer, I love it. Well, thanks, guys. I really appreciate you sharing your knowledge and experience with us today and with the community. And good luck with all of that stuff in the future. Really appreciate it.
Likewise.
Thank you very much.
Thanks for the time.
Hey everyone, it's Rob Stauffer from Side Effects, and I'm lucky enough to be joined today by Matt Pachala. I've known Matt actually now for quite a number of years. He was an intern at Side Effects before going off to have an amazing career. He's worked at places like DNEG and ILM, and currently now at Naughty Dog. And but today more than talking about that, we're going to talk a little bit about Axiom, which, if some of you may know, is a solver that Matt has written. And so, let's go over to that. Matt, welcome.
Hello, nice to be here. Thanks for having me.
Sure. So we're going to dive in. So, what can you tell us about Axiom?
So Axiom is a volumetric fluid solver. And the thing that sets it apart from other fluid solvers in CG is that it's both sparse and GPU accelerated. So it's very memory efficient, and it's also very fast because of that GPU acceleration.
Okay, so that's awesome. That's awesome. So what made you decide to develop Axiom in the first place?
So yeah, there was no one clear goal that I have. I was more curious, more than anything, about both GPU programming, how I can make software go really fast, and also just curious about computational fluid dynamics in general. It just happens to be that both of those things together work really, really well to create interesting things and really fast products and technologies. So over time, I just started kind of putting those two things together and kind of realized that I might have something pretty unique here, something I can offer. So I kept working on it, and that's what's been driving me forward.
So I want to point out that Matt develops Axiom in his free time. So while some of us are doing other things, Matt is just writing a solver at home, because that's what you do. That's what you do in your free time. So
I guess so, yeah.
Do you think that there are things about Axiom that maybe, it's particular types of effects that it lends itself to be better at versus other types?
Yeah, so I consider Axiom to be a general purpose fluid solver. It can do fire, explosions, smoke, missile trails. Because it's sparse, obviously things with weird domains, like a missile trail, for example, that, there might be a lot of empty space in the dense solver they still have to compute. In that case, it can actually ignore empty space and only simulate in areas where you actually need that detail. So it's very memory efficient and much faster for those kinds of situations.
Okay. Are there things you would say, no, Axiom's not ideal for that? Like, we probably shouldn't use that for that.
Oh yeah, absolutely. So it'll get you pretty far, I feel at least. However, if you need to do anything like dive inside, start adding microsolvers, adding custom utility fields, things like that, because Axiom is completely closed off to the end user, you can't dive inside and modify it. I would use something else maybe that is more open and more customizable to do those kinds of effects. Right. And it's a trade-off that I kind of had to deal with just because I wanted the performance. It had to be closed off.
So I know that you've been using Houdini for lots of years and have done some amazing stuff with it. Like, do you think that there are things about Houdini that lent itself to making it easy or a smooth transition to develop Axiom, or make it something that was easy to do?
Yeah, so I have been using Houdini for a very long time. In general, as a tool maker, Houdini is just awesome because it's so open-ended. I have so much access to just the data, being able to manipulate it, how we store it, how we interact with it and create it. It's just very easy to make tools in whatever you want. As far as Axiom is concerned, and even just volume tools in general, the fact that Houdini has such tight integration with OpenVDB, such an industry standard volume format, it just makes it very easy for me to be able to give the users VDBs as an output, and then they can use other Houdini tools to manipulate it, render it directly. And I think it makes Axiom feel like a regular native Houdini tool in that regards.
Cool. Okay. Yeah, that's great. So if I wanted to get Axiom, how would I get it, and how do you install it? What is the licensing and all that kind of stuff?
Yeah, so right now Axiom is free to use, even for commercial projects. Your guys are more than welcome to use it on movies and TV shows, and I think it's actually pretty cool if you do. You can download it at my website, mattpuchala.com/Axiom. You can also do a quick Google search for Axiom Solver. Should be the first thing that pops up. As far as installing it, it's a Houdini package, so it's going to be very straightforward. You just need to drag some files into the right place that Houdini can find. And my website has an install guide, both in written form and a video guide that you can kind of follow along to install as well.
Cool. Okay, that's great. Thanks for that. So if somebody was in your shoes, and I'm lucky enough to remember when we were getting started right out of school, but it's super inspirational, everything you've done with, you have your career and then all this great stuff that you've done with Axiom. And what would you say to someone getting started that wanted to do something like this? Do you have any advice, any tips, any words of encouragement?
Yeah, so it's going to be hard, but ultimately very rewarding, I think. I didn't have a very strong technical, like programming or scientific background when I started off. These are things that I learned along this journey. So to those people, one of the easiest entry points that I can think of is to actually just go into DOPS, drop down your favorite solver, and just start picking it apart, kind of rebuild it from scratch. Then you'll understand kind of how things work under the hood, and you'll start to see things like, hey, I can maybe improve this area. I can add a new feature here. And then you can kind of build from there and make your own solver from scratch if you really wanted to, by learning computer programming and picking up some knowledge about physical phenomenon and things like that.
So do you think you're a programmer now? You feel like you've come to that point?
I've definitely learned a lot, but there's still a lot for me to learn, for sure.
Well, I think you are. I think you've done an amazing job. It's inspiring, especially to new artists out there. So it's great. So, thanks for joining us today. That was awesome. Again, if you want to check out Axiom, it's at mattpicciola.com/Axiom. And nice talking to you, Matt.
Yeah, always a pleasure. Thanks for having me, guys.
Sure.
Hey, it's Chris from Side Effects. I'm here with Jerome Harank from Virtuos Sparks. Hey, Jerome.
Hello, Chris. Good to see you.
Good to see you too. So tell us about yourself.
So I'm art director in Virtuos Sparks, based in Vietnam, and I take care of lighting and VFX there.
Nice. So tell us about Sparks.
So Sparks is an old company now, started 25 years old now, and when I joined Sparks 6 years ago, it was to work on series like Star Wars Rebel, and that was mostly pre-render project. But we switched quickly to game as Virtuos Group is focusing on game, and now we put all our effort to try to propose almost end-to-end solution for game.
Excellent. So you recently worked on Demon's Souls, a cinematic for the release of that game. Tell us about that project.
They contacted us to redo the famous intro of Demon's Soul that was from 2009, the last version, and was really a huge hit. And so a lot of fans was waiting for the next opus. So we have to respect the original product, the intro, but make a fresh new look in 4K with all remaster of all the assets.
So for a cinematic like that, you've got the game side, and you're creating the cinematic. Is there some asset sharing there, and where do the assets start? Do they start on the game side or the cinematic side?
As the game was already in production since a while when we joined the production, so they share with us their game asset, and our work at Sparks, the asset team, was to add detail and like maybe bevel and all the geometry detail, and after improve also the texture to support the pre-render in 4K, and also recreate all the shading because we was using Arnold for this project.
So what were some of the ways you used Houdini on this project?
We use Houdini in many aspects, and first for everything related to FX, which is big volumetric simulation, destruction using bullet solver, all the fire, PO using fire, and after we also generate cloud with the volumetric. We did use Vellum a lot to animate clothes first, a lot of clothes during the fight scene, but also for vegetation to add movement for the vegetation. For the vegetation, we also use the game node skeletal 2D to drive the trees, and use wire solver to add like wind movement in the trees. Destruction, a lot of bullet simulation for the castle destruction, the door, and all those stuff. Flip simulation for the ocean, for the water puddle interaction, and the waterfall with the river. We also sculpt some landscape for the two first shots using Houdini.
Well, speaking of that landscape, maybe you can take us through how that worked, how you executed on that.
So for the landscape, we actually use the geometry, the kind of proxy geometry that we use to animate the camera as a starting point, and we modify that a little bit, and we convert that to high field. Then you do a mask by feature using the slope mask to kind of make a difference between the area of snow and the area of rock. And then you process through the rock, add different pattern of noise to give the rock look of rock. And after the snow, you add some pattern of noise to simulate the wind when it creates some pattern on the snow, and then you add some erosion on top of it to look more natural. And you continue to play like that, adding different detail, pattern of noise to different type of mask. And it's really fun to add different layer of detail like that and export the high field map in 8K and also some mask for shader assignment. And we export that for the rendering software.
Well, it's a beautiful, beautiful project. So really, congratulations on pulling that together. And getting it out to the world. It just blows our mind when we see that work. So great project.
Yeah. I wish I worked with the team.
Yeah. So how do you see a Houdini evolving at Sparks? What's next?
What's next? I think that we continue to use Houdini more and more for game. For sure, we continue to use for the traditional work that is more for pre-render and traditional FX. That's the part that we know really well, and we want to explore more what Houdini can offer for game. So we already have successful start creating procedural assets for game, like some stairs or bridge that you can just drive with some curve. It's really nice and really handy for level designer to use that type of asset. And after we can use Houdini for also the FX side to generate flipbook and output different map like the beauty, the normal, velocity, and sometimes RGB light to help to relight the smoke in-game engine. And after more and more, I think for level set dressing, using the physics, using exploring open world, how we can use with combination of PDG. That's what we want to explore. I think we have a lot to do, and we just scratch the surface right now.
Excellent. Well, thanks so much for joining us today, Jerome. It was great to see you. Thanks for sharing your knowledge and experience, and again, congratulations on that awesome project. And we're looking forward to seeing what's next at Sparks.
Thanks a lot, Chris. Always a pleasure to share with the community.
Hello, everyone. It's Vienna here from marketing at SideFX. I'm here with Hristo Velev, who is the co-founder of a studio in Bulgaria called Bottleship. And he's here to tell us a little bit about himself, how he got started in the industry, to running a studio, and also about the latest project that their studio worked on during lockdown, which I highly recommend. If you haven't seen Space Sweepers already, do so. So, Hristo, welcome. We've kind of known each other. We've kind of known each other for many years now. It feels like maybe because I've seen your name online on the forums for years, like probably Max Underground or CG Talk. So from the Max days, actually. But here we are on the SideFX channel talking about Houdini.
What a journey!
Yeah. So yeah, can you tell us how you got started in the industry as like a 3D guy, and then opening your own studio, which is no small feat?
Yeah, it's quite alright. So yeah, I'm coming from a small town in Bulgaria, underneath the mountains, very pretty place, lots of hiking and skiing and stuff like that. Yeah, but I went to high school for computer science and then to university where I got kind of introduced to the whole computer graphics kind of thing, and I just started playing with particles and stuff, while I forgot to attend my exams and dropped off eventually.
It doesn't matter in the end.
Yeah, but I kept learning the thing, and I kept sending reels around, and eventually one of these got through. So I started with Pixelmondo in Berlin on 2012, and Sucker Punch and Hindenburg, and then moved on to Screen Scene, then to Scanline for Iron Man. And eventually I figured out I wanted to run my own company because, kind of family, there is a family thing with that is, admiring this kind of thing. So I get this learning in the family, and I was looking at partners. So I found Martin, who is my partner now, and he's a really good 3D artist, modeling and lighting and texturing and stuff like that. So we started back in 2013 with some projects that we got from friends of ours in other bigger studios to help them out. But eventually, these led to some bigger connections, and we started making movies. As a vendor, we have I think we started in about 2013, and now we have pretty much, I think, 12 or 13 movies already. And yeah, it's been quite a ride. We have grown to about 20 people, effects, compositing, and 3D. And yeah, it's a good story so far. Let's see, how far we can make it.
So since you were from the Max days, you guys started out the studio originally as a Max house, and there's nothing wrong with that. You use the tools that you need to for the job. But why did you guys start looking into Houdini? Because you have something that works. You delivered the jobs, and everyone is comfortable with the tool. It's kind of crazy to learn new shit, like when when you got to deliver. So like, how, why, when?
Yeah. So basically, in the Max days, it was that's kind of our origin story. That's where we are coming from, and eventually we were ever more into tools like Tiny Particles and Krakatoa and Naiad, which were doing this kind of node-based programming anyways. And eventually we were going full on this side, but development was not very, like for example, things like Naiad got dropped, and we needed more and more to basically happen to cover our projects. But eventually we ran up into a few walls where we couldn't solve the problems that we got. And looking at Houdini, we said, okay, it looks like there we have the same thing, but a bit more evolved. So let's try this one out. And I think end of 2019, we just jumped, and for 3 months we made a complete switch, and we've been extremely happy and extremely excited. It's been just like a roller coaster till now.
So about the Space Sweepers movie on Netflix, you guys did that during the lockdown. With 20 people on your team and a lockdown, tell us about the scope of the project that you had to do. Like, did you have to storyboard, like previs, all the stuff, or just like, here are some explosions we need you guys to do?
Figure it out. There is a portion which is always like this, eventually. But yeah, there's been some designs. Space Sweepers, check this out on Netflix. It's a really interesting Korean sci-fi movie, very outrageous, cool designs. And the stuff we had to do was, again, quite huge. Probably the biggest that we've done. And it covers a huge satellite, many hundreds of kilometers big, that is smashing into the Earth. You're looking at satellite from really close and from very far. You're looking at the way that it hits the Earth from kind of space station angle. Then a huge wave of dust and debris is rolling across the Earth. And eventually we zoom into kind of bird's eye view of a city where the shockwave kind of engulfs the city and eventually smashes some buildings and hits up the camera. All in all, about a dozen shots, I think, but all of them quite complex. And we had 4 or 5 months during lockdown to finish it up. Not too much time, not too many people. But yeah, we did a lot of stuff with Houdini to do on all sides. There's been a lot of interesting procedural modeling for the city and for the satellite. There's been obviously a lot of simulation work with the explosions, and the clouds on the space view towards the Earth. There's been a lot of interesting assembly work, putting all of the assets together to make the city with its active, inactive, and so on parts. And it will be really interesting to speak more about this later when we do the Hive thing, that I can show more.
Yeah, the Houdini Connect is going to be a much more detailed, in-depth conversation with himself, with yourself, Risto. But yeah, I highly recommend everyone to check it out. First the movie, and then basically like a making of. Thank you very much for being here today, Risto.
Thanks for inviting me. It's been really a pleasure.
Hi, my name is Paul Boysen, technical artist at SideFX, and I'm joined by Valentine. Welcome.
Hi, thanks for having me, Paul.
Cool. So we're going to talk about some really cool stuff called machine learning or deep learning. So what does it mean? You know, we hear a lot about it, we see a lot about it, but what does it mean to you?
Great question, Paul. So deep learning is effectively the idea that when you're making a tool or you want to develop an algorithm, rather than sitting down and figuring out how to do this tool, how to go from an input which is provided by an artist to the output that you want to get out of the tool, you don't physically yourself go through and figure out how this should work, what should be the logic of that as you normally go through when you're developing a tool. And instead, you get the computer to teach itself. And effectively, generally, the way this is done is you give it a lot of examples, and the computer runs through those examples lots of times, millions of times potentially, and figures out itself what is the best sort of set of computations to get from, you know, the domain of inputs that you're giving it to the domain of outputs that you want to get out of it.
Cool. So, and then these examples that you give it, you know, what kind of requirements do they have, and how many do you need of them? You know, can I paint a picture of, let's say, a building, and the algorithm can generate a building for me, or what should I think of?
So that really depends. It almost like depends when you're watching this video. I think one of the exciting things about deep learning is at the minute it's such an area of active development. So the process that you'll be working with really depends on the architecture and the neural network that you're working with. So, you know, pretty much every month there's new research papers coming out, and a lot of them, they release their own GitHub repositories of the code to replicate their findings. And, you know, this is everything from doing, you know, working with images, you know, synthesizing new images, stuff like StyleGun, which a lot of people have seen right now, paired image translation. And there's more and more work that's, you know, working with audio, working with text, and increasingly more things are working with 3D data as well, whether that's RGBD inputs from cameras and generating point clouds or voxel volumes and things like that. So it really depends on what project, what architecture, neural network you're working with, and what kind of data it deals in. Generally, the more data, the better.
Yeah, that's cool. I've played around a little bit with it as well in Houdini, you know, using Pix2Pix and some other libraries. You know, which ones have you played with, and what are your thoughts on them?
So most of the R&D that I've been doing has been using variants of Pix2Pix. NVIDIA's released a bunch of really good libraries. They released Pix2Pix HD, I think, 3 years ago now, which is, I think, like a really good starting point, because it kind of, it's fairly easy to set it up and get it going, and actually gives you really good results. Like you get, you know, 2000 by 1000 pixel images out of it, like really HD, quite quickly, as long as you've got the VRAM on your GPU for it. So, and that one is, I believe, under MIT license now, so it's open source, so you can use it for your projects. And they've got some newer ones like Spade, which they showed off with a landscape painting tool. So I've been looking a lot at that as a sort of starting point, just seeing what kind of things can we do with just sort of paired image training, because it's really easy to generate, you know, just large data sets of images, no matter how you're doing it. And it's really interesting seeing how can you actually get utility out of that. Even if you're working in a 3D space, you're not necessarily doing all your work in 2D images, but there's a lot of 2D data that you do ingest. So it's interesting that what you're putting in as your data sets doesn't necessarily have to just be RGB pictures. It can be normal maps, it can be roughness maps, height maps, all of that kind of thing. And as long as you can tweak the inputs and outputs to give you the sort of the operation that you want, and sometimes there's a little bit of going into the Python, making sure that your ranges and the things that it's reading in are correct, because by default it does expect 8-bit sRGB images. But the nice thing is that internally, the way that these networks work, even if they're just image networks, they actually, internally it's all either 16-bit or 32-bit floating point, and it tends to, it doesn't necessarily have to take just the 3 RGB channels, so you can actually expand that a lot. And as long as you can get it to read in your EXRs or your 32-bit TIFFs or whatnot, you can get it to work with pretty much any kind of data that you're after.
Yeah, and so these input vectors, the images or text or whatever it is you want to feed into it, how do you see Houdini fit in this picture?
So Houdini is fantastic for being able to generate a whole bunch of data with it. It's ideal for creating large data sets. The simple example would be, the kind of stuff that even you guys showed off, where you can train a network to go from little sketches of ridges and rivers to creating terrain height map. And, if you want to create like a large number of like randomized terrains, where else would you do it except Houdini, right?
Yeah.
And it's like any kind of data sets, really, Houdini is pretty much ideal for generating. I think some of the stuff I experimented with is we also generated in Unreal and Blueprints because we had some of that stuff set up. But if you just want to, even if you want to say you want to create a network that goes from sketches to say heads of humans, it's so much easier to set it up in Houdini. Just get some 3D heads, and then it takes an afternoon to set up a graph in Houdini where you define your inputs, and then you say like, oh, I want this randomly scattered in front of the camera. You do some rendering, and then after that you batch in some COPS work to say, do me an edge detect and convert this stuff into a sketch. And now you have this paired data set of 3D rendered heads and sketchy heads, and you can start training your network on that.
Yeah, that's really cool. So sort of like, Houdini is the sort of black box that the deep learning algorithm is, right? But then in a sort of way that you can actually run through it and see how it processes the data.
Yeah, and I mean, it's one way of generating the data. It's almost like with deep learning, you can get from any one domain of data to another domain of data, right? Yeah. And Houdini makes it easy to sort of create the very detailed, high resolution sort of output, the nice render. And when you have your endpoint, it's usually a lot easier to create the simplified sort of input, whether that's a sketch or some specific kind of markup that you want your tool to use. It's a lot easier to go backwards from that. And Houdini lets you create this sort of final data set, go backwards from it, and then you train your neural network to go the other way and go from the simplified version to the complicated version, which computationally is a lot harder. And that lets you define how you want that generation to be controlled in particular, because sometimes you don't necessarily have a lot of control, or you don't have the kind of control that you want. Like, you can generate 1,000 different terrains which are all nicely eroded and they look beautiful, but that's not the same as having the control of saying, I want this kind of ridge here and this kind of river here.
Yeah. And the other really cool thing that I like about it, Houdini in this picture, is it's very hard to know what happens in the algorithm, what kind of decisions it makes in terms of weights that it is tweaking. But since you have Houdini, let's say you make a digital asset that creates some sort of terrain or building, you have all these input vectors as inputs, and you can easily wedge them to sort of try and debug how a specific input vector changes the output. So that's something that I wanted to play with. Is that something that you've tried already, or?
So I've not plugged actual. So you're almost talking about like tying parameters in Houdini to the vectors and the latent space of the deep learning algorithm.
Yes.
Yeah.
So instead of having the first layer of weights be automatically generated based on the input vectors, you have those be set by parameter values in Houdini.
That's an interesting thought. No, I've not looked at doing that. What I do like is the fact that when you're creating this deep learning function, you're creating a mapping from this one domain space to another domain space. What's really useful in Houdini is you can say how big these domain spaces are. So if one of the things that I originally experimented with was taking character heads from Sea of Thieves, rendering them out and doing this sort of sketch to, CGI rendered pirate thing. And one of the things that you find is it's very easy to get constrained by what your domain space is. So if all your character heads are, centered and looking forward, you're going to have a neural network which can only create pirates which are in the middle of the frame looking forward. As soon as your sketch is something a little bit more wobbly and sloppy or a bit more off to the side, it struggles. And what's really good with this approach, and especially if you're doing it in Houdini, is you can very much sort of widen your wedges and say, okay, actually, I don't want to just generate pirates in the center. I want to move them around the screen, and you can say how much movement you want, how much rotation you want, and how much you want to randomize that through your data set. And as you widen, because it's really easy to go in there and say which parameters you want to randomize, the more of them you randomize, the wider and more varied your domain space is, and so the better your function that you train comes out of the other end.
Yeah, that's really cool. Thank you for your time. That was a very interesting conversation. Learned a lot.
Thanks so much for having me.
Thanks.
Hey, it's Chris from SideFX. I'm here with Rob and Simon, also from SideFX. So the most exciting thing that we get to do every day is see the work by our customers, just the incredible stuff that's out there being done with Houdini. But it's also important for our team, our TDs especially, to be on the box, to be using Houdini, to be testing it and driving it in some specific areas that we want to go into. And so for 2021, we're creating a demo project called Project Titan that is designed to do that. So Rob is focused on the cinematic side, and Simon is focused on the game playing real-time side, that all bring together this one world, these common assets and this common theme that will go in these two different directions. So over to Rob to tell us about that part.
Thanks, Chris. Like Chris mentioned, we're all working in the same scene. So after Simon did some rough layout, we took some of those assets. We've been working with Mike Golden, who has done a lot of concept art with Kitbash 3D, and we're using some of those Kitbash assets as well. So we thought it'd be great to work with Mike, since he's sort of worked with those assets before, to help us come up with our environment and our look. We're also working with Scott Keating internally to do some character art for us. And Kenny and Hardy, a couple of interns that we have right now, are already getting started on the previs on the cinematic side. So taking sort of Simon's rough layout, bringing it into Houdini, and starting to flesh out the camera moves, with the ultimate goal of doing all the lighting in Houdini. We want to explore some of the new KineFX tools, and maybe even some elements of virtual production, getting some cameras out of Unreal and into Houdini, and doing some mocap and things like that.
What about you, Simon? Tell us about your side.
So for Project Titan, I'm going to focus on the real-time side, so the game side. And we really want to show Houdini's power inside of the game engines. So we're going to use Unreal Engine, and we're going to build procedural tools. And we really want to build a city that city and environments that show off procedural tools and procedural nature. So we're of course going to heavily use Houdini engine, which allows us to use procedural tools from Houdini into game engines. So that's going to be really interesting to show everyone how you could build these things.
Thanks, Simon. And yeah, the whole concept of Project Titan is that it'll take the full year, but we'll be releasing it along the way. We'd like to be working with some really talented external artists out in the community. And so stay tuned along the way and we'll keep you posted.
Hi, I'm Jeff Wagner, Senior Technology Consultant at SideFX, and today I have the extreme pleasure of interviewing Rob Hopper, Head of CG at Union Effects. Today's focus on the Illume has to do with KineFX, but pulling back a bit, it's also about pipeline, the decisions that we make around dealing with character, dealing with effects work, creature effects. And I've had the great pleasure of meeting you very early on, several years ago, when you were working at one of your many stints at MPC. And I have to say, you know, if you just go to IMDb and take a look at all the work that you've been involved in, it's a hit list of all the top features and all the top effects work. So when I first met you, it was awesome. And now on to your current efforts and exploits at Union Effects. So KineFX and crowds. Character effects are playing a larger role, and there's this whole integration with effects. And the way I've always conceived SOP-based rigging, you know, saw the power in this early on, working with a couple developers in-house, and sort of started off with VEX code, you know, writing simple rigs and writing kinematic solvers from legacy workflows from Softimage, ICE, and then sort of progressing to the point where we are right now, where we have a brand new framework to represent a character. And the way it's positioned is that it's a glue. It purposely designed as a glue to bring in rigs from Maya, from FBX, from Motion Builder, and from USD now, even in and out, and try and make that as lossy as possible, moving to joints and all of that. What do you see as the most beneficial part of the KineFX SOP-based rigging?
Well, already, I think in a similar way to MPC, we kind of started introducing Houdini to our kind of character pipeline via crowds. Having used, looked into different solutions and different strengths for that historically at Union, and crowd is a big part of what we do. We've decided again to kind of consolidate on Houdini, again, because of once if we can do as many things in Houdini as possible, we're going to save ourselves the pain of constantly, trying to go backwards and forwards. So we've already done some testing with KineFX. The retargeting kind of workflow has been very useful, and that we've managed to, along with PDG, process like libraries of animation clips using the retargeting workflow to conform everything to our own rig. And now we've got an animation library that we can feed to our crowd without having to worry about capturing from different sources, or some of it mocap. We can collect everything in one place, and that's then our with relatively little kind of development effort on our side, we've kind of built a library that's in our own specifications for animation that we can use for crowds.
Oh, that's awesome to hear that we're right on target. That's great. Yeah.
I was going to say, we also done a bit of work using the kind of some of the post simulation workflow, where we can add, using the SOP-based rigging, we can add a little bit of randomness to animation clips. So if you've got a fairly finite number of variations of animation clips for a crowd, we could then go in and add some random offsets, or to individual joints using the SOP-based rigging, to then just bring that extra bit of variety to the crowd without having to add more animation. So and there's a lot of potential there.
And it's all SOP-based rigging, right? So it's just points at the end of the day. And the fact that we have the agents now living alongside the KineFX rigs, it's points at the end of the day now, which is, it's really great having that in the geometry format. How do you see using that moving forward? Are you going to take a look at using more KineFX to do more character work? Let's say moving more of the animation side, passing it through more KineFX?
Yeah, we are looking at things like using it for helping us capture the motion capture data, putting that through a Houdini graph. I think we can do like a live kind of connection and try to speed up the way that we capture data. We've also been using it slightly unusual, slightly maybe less typical ways to create a clothing library to try to create these variations for our characters. We've managed to use the retargeting workflow along with some of the topology nodes that you have in Houdini to kind of be able to source clothing libraries from a wide variety of places and again conform them to our union characters and build a library of those that we can build quickly, very quickly build up a huge range of variations of characters that we could just use across lots of different shots. And I don't know, in general, again, that kind of interplay between different disciplines, running cloth simulations, looking at maybe the muscles side of things. These are all things that we, plan to investigate.
So it's been a pleasure. It's going to be exciting to see what directions Union takes and your career takes. And I'm looking forward for the IMDb list to just keep on rolling. And you've got an amazing team there. The structure. I always am a big proponent for education, and as a TD or a TA working in a production, always learn more, expand your horizons, and try to become as independent within the system as you possibly can. And you're building that team. Congratulations on your move, and looking forward to see what Union does in the near future. Thank you so much, Rob.
Thank you very much.